In this module, we will learn how to compile a standalone app that can be installed on a device. The first thing we will do is walk through the steps to compile an iOS app. Since I am not a Mac user, this will just be a discussion about some of the steps you need to take when compiling an iOS app. Then we will compile an Android app from the project. This will include the process of signing the app with an upload key. Once we have the app compiled, we can test the build in the emulator. Here we will confirm all the features of the app still work correctly. We will get started in the next clip by going over the process to compile an app for iOS. In order to build an iOS app from a React Native project, you will need a Mac. This is because Xcode only runs on a Mac. Xcode contains all the tools you need to build iOS apps. It also provides a simulator that you can use to test your apps. You can build an app for iOS without a Mac if you use Expo. Expo provides a suite of services that make React Native development easier. We use the React Native command line interface workflow for this course instead of using Expo. There are a few things you will need to do in order to compile a build of your iOS app. The first thing you will need to do is enable App Transport Security. App Transport Security will reject HTTP requests that are not sent using HTTP Secure. App Transport Security is disabled by default to make it easier to build iOS apps. Before you compile a build of the iOS app, you will need to enable App Transport Security. You can enable App Transport Security by removing localhost from the NSException domains dictionary. You will also need to set NSAllows arbitrary loads to false in your info.plist file. As an alternative, you can enable App Transport Security using Xcode by opening your target properties under the info pane. There you can edit the App Transport Security settings entry. In order to distribute the app on the Apple App Store, you will need to enable the release scheme. Building your app for release will disable the in-app developer menu. This prevents your app users from accessing the menu from your production app. The release scheme will also bundle the JavaScript locally. This offers the advantage of being able to load the app on a device and test without being connected to a Mac. In order to enable the release scheme, you need to go to the product menu in Xcode. From there, you need to go to Scheme and then Edit Scheme. After that, select the Run tab in the sidebar and then set the build configuration to release. After you enable App Transport Security and set the release scheme, you are ready to build your app. In Xcode, select Product and then Build from the menu. You can also use the React Native command line interface to generate a build of the app. You need to use the configuration option set to release. There are a few more steps that you need to perform in order to publish your app. Since I don't use a Mac, I cannot demonstrate the process. For a better understanding of what you need to do to publish your iOS app, make sure to check out the documentation. Any app that is distributed on the Google Play Store needs to be signed with the release key. App signing by Google Play will sign your app with the release key automatically. Before you can upload your app to the Google Play Store, it needs to be signed with an upload key. Navigate to the path in the file system where you want to save your upload key. The key tool is installed as part of the Java Development Kit. It will be in the Program Files, and then the Java folder, and then your installed version of Java. In my case, my version of Java is 17.0.4.1. Inside that folder is the bin folder. This is where the key tool can be found. This is the path I would have to use to access the key tool. Yours will be based on the version of the Java Development Kit you have installed. Adjust your path to reflect the version of the Java Development Kit that you have installed. I have taken the liberty of adding this to my path system variable. This allows me to use the key tool without the full path. This is not necessary if you aren't going to be using the key tool on a regular basis. It is more of a convenience since the key tool has a lot of options. Globalmantics.keystore is the name of the key store file that will be generated with this command. Global-alias is the alias for this key. We are going to need this when we sign the app with the upload key. Then the last thing to take note of is the validity of 10,000. That means this key will be valid for 10,000 days. When you run the command, it will prompt you for a key store password. Then it will prompt you for information that will be added to your key. Then finally, you need to enter yes to confirm. Once you have your key store generated, copy the file to the Android app directory in your project folder. After that, we need to edit the Gradle.properties file in the Android folder. The My App Upload Store file is where we add the key store name. The My App Upload Key alias is where we add the key alias that we created when we generated the key store. Then the My App Upload Store password and My App Upload Key password will be the password that you set when you generated the key store. In order to avoid any problems, the store and key password are the same. This will create the variables that we will use to sign the app. Then finally, the last thing we need to do is add the signing config to the build.gradle file. This file can be found inside the app folder, inside the Android folder. Then scroll down until you find the Android configuration. Then inside the signing configuration, we are going to add a release configuration. Here we use the variables that were added to the Gradle.properties file. The conditional checks if the project has the My App Upload Store file property. If it does, it will use this property as the store file. This property, of course, references the key store that we generated. We also use the variables for the store password, key alias, and key password. Then the last thing we need to do is go down to the build types and set the signing config for the release build type to release. By default, it's set to use the debug build type. Go ahead and save your project. We are now ready to generate a build of the app. In a terminal, navigate to your project folder, then navigate to the Android folder. In order to build the app, we use the Gradle W command with the bundle release option. Now you may see some messages as the app is compiled, but they are mostly just warnings about features in some of the packages that we used. It may take a couple of minutes for the app to be compiled. This will generate an Android app bundle that can be installed on an Android device. This Android app bundle file will be in the Android and then app, build, outputs, bundle, and then the release folder. Now that we have created a release build of the app, in the next clip, we will demo the Android app bundle file that we just created. In this clip, we're going to launch the Android app bundle that we compiled in the last clip. The first thing we will do is launch the Android app bundle on the emulator. When the app starts, we will test the login and registration to ensure they still work properly. After that, we will test the blog to ensure it still works. Then we will check out the quiz to ensure it is also still working correctly. In order to launch the app, we first need to open Android Studio and start the emulator. Once the emulator is up, go into the settings. Make sure any instances of our app that may have been installed as part of testing are removed. After that, navigate to your project folder in the terminal. Since the app has already been bundled, we do not need to start the Metro bundler. Instead, we will use the run Android command. The only difference is that we now add the variant option set to release. This will launch the release version of the app, which is the Android app bundle that we compiled in the last clip. In future versions of the React Native command line interface, the variant option is being deprecated in favor of the mode option. This has already been reflected in the documentation for React Native, but does not work for the version of the command line interface that is returned by NPX. Bear in mind that in the future, you may need to substitute mode for variant. The Metro bundler will start, but once the app is launched on the emulator, we won't need it anymore. In order to verify if this is the release version of the app running, try and hit Ctrl-M to open the developer menu. If you can't open this menu, then you can be sure this is the release version of the app. Go ahead and tap the button to register an account in the header. As an alternative, you could also use the menu to navigate to the registration page. Once there, register a new account. Make sure to enter a matching password. After you create the account, go ahead and log in with this new account. Then after that, tap the blog button. Select the blog post and verify that it still loads correctly. Then make sure the back button works. After that, go back to the home screen and then tap the button for the quiz. Work through the selected quiz and answer the questions. When you finish the quiz, verify that the quiz finish page reflects the score. Then go back to the home screen one more time. This time, tap the Lessons button. The list of videos should be displayed. Select one of the videos and play it to verify the videos are working correctly. You now have a complete Android app that could be released to the Google Play Store. There are many improvements that we could make, but we have a solid foundation. Congratulations on finishing the React Native Fundamentals course. You should now have a complete app that can be installed on the device. We got started by learning how to set up a development environment to build React Native apps. Then we learned the basics of React Native. This included the core concept of creating both class-based and functional components. We also got familiar with some of the core components provided by React Native. After that, we added a registration feature to the app. This allowed users to register an account and log into the app. Then we added a blog feature. This displayed posts from a WordPress site which we used as a data source. Since the app we were building was for a company that specializes in training, we added a quiz. The quiz will allow users of the app to test their knowledge. We also added a video feature that used the YouTube Data API. This allowed us to search for videos that we were able to display in the app. Users are able to select and view any of the videos that are listed. And then finally, we compiled a build of the app. Ultimately, we are building a mobile app that we may want to distribute on either the Google Play or Apple App Store. In order to distribute an app in these stores, it needs to be compiled to a package that can be installed on the respective device. Now, the app may be complete, but it can be improved in many ways. Even though I applied some styles while building the app, the main focus was functionality. As a result, the app does not look the best. Now that we have a prototype, we can go back to the app and improve the look of the components that we have built for the app. We can also update the WordPress site that powers the blog. This means adding posts to provide more content for users. We can also improve the video component by providing a better search string to return more videos. Now that you have completed this course, you may be looking to extend your React Native knowledge. Fortunately, Pluralsight has a lot more content focused on React Native. If you are looking to learn more about React Native, building mobile apps with React Native will be a good place to start. Or as an alternative, you could follow up with building React Native apps using Expo. Expo makes building React Native apps easier and even allows you to build mobile apps remotely. TypeScript also works with React Native, and it is a good idea to use if you are working as part of a team. If you aren't familiar with TypeScript, building React Native apps using TypeScript is a great way to get started. I am Reggie Dawson, and I want to thank you for joining me on this journey to learn the fundamentals of React Native. You should now have enough knowledge to build your own app for release on the respective app store.